many questions would be there from my 2 lectures, 2 sessions, today and tomorrow?
Sir, you can send 7 or 8 tomorrow. I will take about 15 from Jay Kumar. Totally, I'll put 20. You send 7 or 8.
7 or 8. Okay. Yeah, I think participants may note down. Whatever I will be discussing today and tomorrow, I would include 7 to 8 questions from there. It's very easy, I think. If you follow in the tomorrow's sessions, directly you can answer. No need to even practice. Such a way I'll set up the questions. Okay, right? So yeah, I think maybe a minute break. Yeah, there is a question. Is the quiz will be on the canvas? Yes, it will be on the canvas. Yeah. In your profile somewhere, I think instructions would be given later. Okay, so you can find that. Okay, then let me get back. Reduction method. Okay, when I'm not able to do separable method, I will go for a reduction method. I'll go for some other integrating, multiplying by some integrating factor. Okay, right? So now, so people have asked me how to guess. Probably as we go through several examples, we will get to find a knack how to guess the solutions, right? Okay, now let's say I have a differential equation of second order DE I have. Okay, right? It's not that easy to solve every time. Okay, because it has independent variable, dependent variable, first order derivative of dependent variable, second order derivative of dependent variable. These are the things involved in the differential equation. Okay, now it's not that straightforward to find the solutions. Let's say there is a catch. If at all, if x or y is missing in the differential equation, then you can play a trick. Then you can play a trick. Through that trick, you can easily find the solution. What is the trick is, let's say y is missing, dependent variable is missing. Okay, in the given DE. This is a scenario. In that case, what you can do, there is something called you can define a new variable. You can define a new variable, let's say called P is equal to which is equal to derivative of that function y. Okay, if that what is that implies is y double derivative is just a p prime p derivative. So in this way, what happens, you can reduce the higher order differential equation. So you can reduce second order d's to first order d's. Importantly, there will be two equations involved. One is y equal to p, sorry, y prime is equal to p prime, y double prime is equal to p prime. So these two differential equations one has to solve. Okay, so let's take a simple example. Understanding the reduction method. Let me give you an equation where x into y double prime, okay, minus y prime is equal to 3x square. This is a differential equation. Okay, right? If you carefully see here, what is missing, x is there, y is missing. Okay, literally I'm talking about among the various possible elements exist in a second order differential equation. There are 4 things must exist. Among them, this is missing. If that is missing, like say the technique I said is let's introduce y prime is equal to p. Okay, so which implies what? Y double prime is equal to p prime. Okay, let me substitute these things here, which is x into p prime minus p is equal to 3x square. Now see, I got a first order differential equation. Not only that, I have one more first order differential equation, which is y prime is equal to p. So there are two first order differential equations. This is one, this is two. Okay, I can easily solve both of them because for me handling a single first order derivatives is easy, right, than handling the second order derivatives. Okay, so now these two things can be easily solved because they are first order. If I'm able to separate them, I'll just separate them using a separable method. Or if I'm able to find the integrating factor, well, I'll just multiply that integrating factor throughout the equation. By doing that, I can easily find a technique to reduce the equation to easily integrable form. That also you can do. Okay, right? So we can see one example, I think. Okay, right? Okay, let's see. That is this example itself. You can try to solve through this example itself. It's very easy. Okay, now let's say I have something is missing apart from x, y, y prime, y double prime. Let's say x itself is missing. In that scenario, again I'll do the same technique. Okay, if that is missing, if independent variable is missing, independent variable is missing, then you do the same introduction. Y prime is equal to p, but remember y double prime is equal to dp by dx, right? Okay, so one small technique or small trick we will play is, as we know, p is a function of y prime, means p may be a function of y also. So I'll have this is equal to dp by dy and dy by dx. Okay, by the way, what is dy by dx, which is y prime, which is dp by dy into p. Okay, right? So with this substitutions, let me take one differential equation. Let's say I have a differential equation y double prime plus k into k square into y is equal to 0. Let's say I have a differential equation like this. Here, for sure, x is missing. What I'll do, let me substitute now whatever the constructions which I was doing. One construction is this, another construction is y prime is p, y double prime is dp by dy into p. Okay, these are the two substitutions which are making. Let me do that. Dp by dy into p plus k square into p. Sorry, I'm sorry. There is no y, no y prime here, so I'll have y as it is equal to 0, right? So this is the equation I have. Now I can try to do maybe a separable method. Is it possible? Let me see. Dp by dy into p is equal to minus k square by y. Of course, yes, I can send dy to the right side. So I'll get integration of p into dp is equal to minus k square. Let me take k is independent of y into dy. Okay, on the left hand side what I get is p square by 2. On the right hand side I have minus k square into y by 2, y square by 2, I'm sorry. Okay, plus some constant. We should add that constant. Okay, because we have not substituted specific limits. Now what is p square? Send 2 to the right, I'll get minus k square y square. Let me call this as c prime. Okay, 2 into c, let me call this as c. Okay, so this is my equation. Now explicitly, if you want to find what is p, p is square root of, there is a minus sign is there, so I'll have plus or minus square root of minus k square c square plus c. Okay, right? So p would be equal to, I can bring a k common to the out, which would be c minus which would be c minus, okay, this is okay. So what I have here is integration of, sorry, dp, I'm sorry, equal to, I'm trying to remember, minus k square y dy, p square by 2 minus k square by y square by 2 plus c. Okay, okay, just a minute. Okay, this is I have, so which becomes p square is equal to minus k square y square plus 2c. Okay, right? So when I take common plus or minus k, right, c minus, okay, c minus y square, right? So let's say all c by k square is there anyway, I've taken common, no? So that is, let's say this entire term, let me call as some e minus y square. Okay, by the way, what is the p? P is dy by dx. Okay, now I do the separable method, dy by k plus or minus e minus y square is equal to, okay, plus or minus, okay, k, let me not take k to the left, keep it on the right, k into dx, right? So now I have left hand side only y terms, right hand side I have x terms, so I can do the integration. Okay, so you see one thing here, this is a particular kind of a exponent, sorry, integrand. Okay, for this integrand, the solutions by default are given, which is, okay, so remember integration of sum a minus a square minus x square dx is actually sine inverse x by a. This is a solution, some constant, if I don't know the integrand x. Okay, so if you just see here, okay, and that this equation also looks like this kind of a equation. So the solution on the left hand side is sine inverse y by square root of e is equal to, on the right hand side what I have, plus or minus k x. Okay, plus some constant, let me call some f. Okay, that would take care of it. Now send the sign to the right, I'll get y by square root of e is equal to sine of kx plus some f. Okay, y is square root of e sine okay, this is playing tricks. Okay, Okay, so differential equation y double prime plus k square y would have solutions like what? Y square root of e sine, okay, plus or minus kx plus some f. Oh, what is happening? Continuously happening this. Okay, so I in that way by reduction by introducing new variable, okay, like what? Y prime is equal to 3 when y is missing, okay, when x is missing, okay, when x is missing, in this case I'll introduce y equal to p, and also I'll introduce y double prime equal to dp by dy into p. So this is very, very important. So if you do this, you can easily find the solutions. Okay, right? So now the question people were always asking, how do I guess, right? It's always tough to guess, but if there is a linear differential equations are involved, linear differential equation in the sense there is a y, there is a, okay, there is a y double prime and y, everything is involved in these equations. You can just check, okay, right? So let me take a simple example. Like say there is a y double dot plus y single dot, okay, plus is equal to, let's say, d. So there are all constants are there, okay, linear differential equation. This is second order linear differential equation, because see y double prime, y prime and y, none of them are multiplying to each other, they are not coming together. So that's why I can simply say it's a linear differential equation. Okay, it's a linear second order differential equation. Okay, it's second order differential equation. In this case, what you can try is you can just guess. Okay, now there are constants involved here. Okay, let's say the simplest scenario is the simplest scenario. Okay, scenario is, let's say, d equal to 0. So it is called a homogeneous differential equation, right? So differential equation becomes homogeneous if there are no, if there are, if so the single, see there is a variable y here, it is getting multiplied. So there is a constant here, it is not multiplying to any variable, dependent or independent or derivative, first order or second derivative. If that constant becomes 0, then these big equations are called homogeneous. Why they are homogeneous? I'm saying, okay, I can directly relate y to y prime, I can directly relate y to y double prime. So in the way, actually they cancel each other. Okay, right? So how they cancel each other? Let's say I'll introduce a guess function. Let's say y of x is equal to exponential some rx. Okay, so if I guess this exponential rx solution and try to put back here, okay, I don't know whether it's solution or not, but I just trying to guess. So let's substitute a into exponential second order derivative of exponential rx plus b into first order derivative of exponential rx plus c into exponential rx is equal to 0. Okay, now first derivative gives me what? 1r. Okay. Another term is as it is. Second order derivative gives me two terms, r square. Okay. So let me take r e to the power of exponential rx common. So what I'll get is, okay, ar square plus br plus c exponential rx is equal to 0. Okay. Now if you carefully look at this solution, look at this equation is true, okay, when rx is equal to true 0 or ar square plus br plus c is equal to 0. Okay, one of them must go to 0. If let's say rx is equal to 0 means what? Okay, which means rx is minus infinity, exact value, specific value. Okay, but I am talking about x is equal to minus infinity only. Okay, only in that situation this is going to be 0, but my x value would increase or change, right? So that is what I am going to intend. I change the x and try to get the function value. So that means I cannot consider rx, exponential rx is equal to 0. So only scenario is exponential rx is not equal to 0. So that means ar square plus br plus c is equal to 0. Okay, so okay, what I am doing is ar square plus br plus c is equal to 0 only, which means this would give me a solution in such a way that r value which is equal to, like, this is a quadratic equation, remember it's a quadratic in r. So I can find the solution which is minus b plus or minus square root of b square minus 4ac by 2a. Okay, the moment I know r, I can just get what is the solution. Okay, so y of x is exponential rx. So any given differential equation, let's say a y double prime plus b y prime plus c y is equal to 0 would have solutions like this. Okay, so now how many such solutions are exist? We don't know. There are several solutions may exist. Okay, right? Several solutions exist. So that means one has to keep on finding the solutions. How long? Again, what kind of differential equations we are talking about? Since this is a second order differential equation, okay, which means I have to find at least two independent solutions are required to describe the system exactly. Okay, so one example you can just take example. Let me take a simple example. Let's say y double prime minus y single prime plus 4y is equal to 0. It is linear differential equation. It is second order linear differential equation, and also it is homogeneous differential equation. Okay, now let's say I just start with a guess, exponential rx. Is it a solution? Yes, it can be definitely a solution because it's a linear differential equation. Huh? Let's substitute y equal to erx. What I get is y equal to erx, y double dot, y double prime means r square exponential rx minus 5 into r into exponential rx plus y 4 into exponential rx is equal to 0. You can just reduce this into simpler form, r square minus 5r plus 4 exponential rx is equal to 0, which implies there is only possibility is this. Okay, now what is the solutions for this quadratic equation? Very simple. You can write the quadratic equation as r square 4r minus 1r plus 4 equal to 0. I can do that. And take the r common here. r minus 4. Okay, minus 1 common if you take, r minus 4 equal to 0. r minus 4 if you take common, you will get r1. So which implies r is having two solutions. You see, that means there is a y1 which is exponential rx is equal to, with r equal to 1, exponential x. There is a y2 with exponential rx, r equal to 4 is equal to 4x. So there is two independent solutions I have. So this is something like that, and this is something like that. Okay, some two different solutions. So there is a general solution you can find, or you can write down it as y is a into exponential x plus b into exponential 4x. This is a general solution of this above differential equation. This differential equation. Okay, so if it is a third order differential equation, you have to find at least 3 independent solutions, and from the 3 independent solutions you have to find a generic solution. Okay, so another example. So this is straightforward, right? So I am able to find the straight solutions from the quadratic equation. Let's take, I am not able to find a quadratic equation there. So let's say I have another example. Let me take an example. Let's say 2 into y double prime plus 6 into y prime plus 2y is equal to 0. Okay, let's start with the substitution exponential rx. What you get is 2 into r square exponential rx plus 6 into r exponential rx plus 2 into exponential rx, which implies 2r square plus 6r plus 2 is equal to 0. Okay, even you just take a common of 2, what you get is this. So this I can't separate into two factors. So only way is to find the solution. Minus b is what? Minus 3 plus or minus, okay, square root of b square is 9 minus 4, a is 1, c is 1 divided by 2 into 1. So which is minus 3 plus or minus 9 minus 4 divided by 2, which is minus 3 plus or minus square root of 5 by 2. Okay, what are the two independent solutions? One is exponential minus 3 plus square root of by 2 into x. Another one is minus 3 minus square root of 2 into x. Two solutions. So you can write a general solution as general a into y1 plus b into y2. You can check whether this is going to satisfy the given differential equation. You can check. In fact, it satisfies. There is a general solution. Okay, right? So, and another interesting, let me take another interesting example. Okay, another example. This very, very tricky example. Y double prime minus 6y prime plus 9y is equal to 0. Okay, now it's a second order differential equation. We have to find at least two independent solutions. Okay, let's try to do that. So how I am going to do? I am going to substitute which gives me r square minus 6r plus 9 is equal to 0, right? Okay, so I just try to put this into simple form. Minus 3r plus 9 is equal to 0. If I take r common, r minus 3 common, r minus 3 is equal to 0, which is r minus 3 into r minus 3, which implies what? R is just to value 3. There are two like solutions. What it means, y1 is exponential 3x, y2 is exponential 3x. It is not, right? Both are same. So I have a second order differential equation. I have only one independent solution. So what I have to do in this case to generate a generic solution is you have to guess another possibility. Another possibility is, let's check whether y equal to exponential 3x is solution or not. Okay, if you just check, let me take a y prime, which is x 3x plus, okay, right? When I differentiate okay, let me remove that. When I differentiate 1 x first, I'll get 1 exponential 3x plus 3 into exponential. Okay, this is a solution. Okay, what about y double prime? So y double star is 3 into exponential 3x plus 3 into, okay, exponential 3x. I'm differentiating this now. So 1 is plus 3x exponential 3x, which is 3 exponential 3x plus 3 exponential 3x plus 9x exponential 3x. This is sums 6 exponential 3x plus 9x exponential 3x. Okay, right? So let me substitute into my equation. What the equation I have is y double prime, okay. My equation is y2 into y double prime plus 6y prime. No, I'm sorry. Y double prime minus 6y prime plus 9y is equal to 0. Now, let me substitute what is y double prime. Y double prime is this 6 into exponential 3x plus 9x exponential 3x minus 6 into y prime. What is the y prime? Y prime is exponential 3x plus 3x exponential 3x plus 9x exponential 3x. Okay, this is what we have, right? If you just to try to find this, it is going to be 0. So which means x 3x is also a solution, which I am calling it as y2. So the overall general solution would be a into exponential 3x plus b into x into 3 exponential 3x. Okay, this is how we have to keep on generating independent solutions. From the independent solution, you can find the generic solution. Okay, right? So yeah, there is a 5 minutes more. I want to cover complex scenario. Okay, for non-homogeneous case, okay, it would take some time for non-homogeneous case. Okay, so I'll just stop at this point and see whether any questions are there. Okay, so there is a question now. Let me summarize. From the second order differential equations, if x is missing, okay, there is one way. X missing, there is one technique. If y missing, another technique. Okay, so what are the techniques is, okay, let me take an example and show you. Right, okay, when y is missing, what you do is we just introduce y prime is equal to p and y double prime is equal to just a p prime. That's all. That is what you do. And when x is missing, in that case, will you substitute y prime is equal to p and y double prime is equal to p prime, okay, which is not just, this is p prime is dp by dx, na, which is equal to dp into dy into dy by dx. By the way, this is p. So y double prime is p into dp by dy. So these two conversions I would be doing. Okay. If you do this, Depending on what independent variable missing, this is a conversion. Dependent variable is missing, this is a conversion. So you would easily reduce the differential equations into much simpler way so that you can follow it. Okay, so which book you are following? Yeah, very good question. So the book which I am following is, let me show you this book. Okay, this book, Steven Krug. Yeah, it is available on the net freely. It's a nice book though, right? Differential equation, theory, technique, practice, the boundary value problems of this book. Okay, right? So I'll stop here, right? So to summarize, we talk about what is differential equation, summary. What is D's? Among the D's, first order, second order, okay, right? Among the first and second order, there is something called linear and non-linear. We have not gone to non-linear, but we know how to identify them, linear. And also we talked about something called homogeneous and non-homogeneous, right? So in solving this differential equation, we used a separable method, okay, and finding integrating factor method, okay, and reduction method, right? There is one more method is also there, okay, very interesting method. I think for the quantum computing, probably we may not needed that, but we will see if time permits. We'll get into that method. In tomorrow's class, we'll just discuss about the specific scenarios when the constants which I actually see, the constants which were there involved here. Okay, so for example, in this equation, the constants are not functions of x, they're constants. If there becomes a functions of some variable x, how to solve that we will see in the next class, next session. So I am like, this is my notes, okay, so it explains everything, right, neatly. Maybe small okay, there is an error, small typo here, for example, in this equation. Okay, only small things, but not many. When I remember, I have noticed that small correction, but other than that, everything is 95% is perfect. Okay, so you can go through it. Okay, and yeah, we have covered up to here, I think. Complex scenario we have not done today. Up to here, okay, up to page number what? Page number 16. Okay, up to page number 16 we have done. So remaining 6 pages, we will start tomorrow, and then we'll go to the variable constant, variable second order differential equation with the variable coefficients. Okay, that we will do it tomorrow. Fine. Yeah, definitely. I will be uploading the notes. Pillai sir, if you can add me to the canvas, this QT-03, I'll immediately upload my notes so that people can go through it. Okay, right? So I would say maybe 4 questions from today's lecture, maybe 4 questions for tomorrow's lecture, like that I will plan. So 8 questions.
Sir, you are not there on the canvas?
QT-03, I'm not sure.
Okay, sir. We'll check.
QT-03.
Right,
I am there in QT-01 and 2.
01, 02, you are there. Yeah, I'll just add.
Maybe QT-03, I have to get added up.
Radhakrishna will add 1 minute. Today you will get the invitation. I am sending in 5 minutes. Yes.
Okay. Okay. I'll add it.
Yeah, sure. Your session is over, sir?
Yeah. I'll stop the session now.
Right. Okay. Any questions? Please continue. Otherwise, we'll. Participants, have any questions?
Yeah, there is a question. People are asking me, will you be discussing about programming for solving DEs? Yeah, definitely. I'll just touch upon that. I'll show you. But exact hands-on solve, there are plenty of methods in numerical integration. All those things require some extra session or so. So depending on the availability, when Pillai sir gives me another session or so, then I can show you explicitly. There are various methods are there, starting from something called Euler method, Euler-Kramer, okay, and then go to RK4 method, RK2, RK4, and so on. These methods are very, very powerful methods. Okay. So these methods I would like to show, and then you can also practice yourself. Partial differential equations differentiation also. See it if time permits. Okay. So whatever is required for the quantum computing syllabus, I am just trying to cover. Partial differential equations, I'll see. Yeah.
Thank you, sir. On June 3rd, we have a quiz slot. I'll just see, but actually it is going beyond 40 hours. So I'll just see how best we can adjust, sir. I'll try to look at it, right? Yeah, sure.
So somebody was asking me the book name again. Let me give the name of the book again. Okay, this is a book. Okay, just a minute. It's a Stephen G. Krutch, Differential Equation by Stephen G. Krutch. Okay, I will just type here Stephen G. Krutch. D. Okay. If you search differential by Stephen G. Krutch, you would straight away get that. This book, you will get that. Crunch, I'm sorry. Crunch. K-R-A-N-T-Z. It is there available on the net for free. A nice book I saw. The Simmons book is the one which usually people use for master's level, MSc mathematics and so on. But this book, I find it very like elaborative, and nice examples are also there in this book. Okay. So somebody wants to practice plenty of problems to get acquainted with the solving differential equations, you are welcome to do it. It's a nice book. Okay. See you tomorrow sharply at 2 o'clock. Yeah, over to Pillai sir.
Yeah, thank you, sir. Thank you so much for your time and for the commitment for this thing. And then tomorrow we'll have these questions also, and we'll look at how best we can accommodate the programming part. Anyway, when the simulations are done, we will do that. So we'll go into that part clearly. And Ritajit also will do that some part, and Mustafizur also will do some part. So let's see how best we can do it. Actually, this is the other QT-03 is more theoretical, but QT-04 was again hardware related this thing. So let's see what best we can do, right?
Yeah.
So thank you so much, sir. Thank you all participants. Tomorrow we'll join at 4. We'll set up the quiz, and quiz will be open from 4 o'clock tomorrow. So best you can do.
2 to 4 regular session will be there.
Regular class will be there. After the class, the quiz will be open for 32 hours, sir. Next day till midnight they can attend. So, and in fact, some people, if they miss, we again open for one more time. So that is not a problem. So they can, within two days or something, they can complete, right?
Yes.
So if somebody wants more time, we will give time. If you want, we will open it for 2 days, because sir's lecture will over tomorrow. So though some people want to attempt immediately, sir, because they have prepared till today's lecture. After listening tomorrow's lecture, they will prepare for half an hour or something and write the exam. So that way it's okay. So for them, we are keeping it open. For the others, they can do in the next 2 days maybe. We'll open. Sivan sir, anything you would like to add?
Yes, sir. I would like to thank Ashwath sir for a very informative session. I think and very detailed session he took. Thank you, sir. And thank you, Billy sir, and thank you, Vikas sir, for being here.
Right. Yeah, actually, Ashwath sir's handwritten teaching, na? So it's almost like classroom, sitting in the classroom and going through. Some
Exactly, sir.
participants are making notes, so that's very happy to see that you are following and making notes. It's also going. Yeah, quiz is going to be multiple choice, four answers, but some questions may have multiple answers which may be correct. So slightly tricky. So you have to be careful when you are.
You can go by elimination method. You, instead of picking a right answer, you can just check what are the wrong answers.
Correct.
That
Correct.
way you would
Right.
able
That's a good
to.
approach.
Yeah.
Sure. Thank you so much.
Yes.
We'll wind up for today. We'll join back tomorrow at 2 o'clock. Thank you so much. Yeah.
Yes.
Thank you.